everyone. Myself Piyush Gupta. I want to present a linear algebra presentation. First of all, I introduce myself. My education qualifications are I did my BSc Maths Honours from Deshbandhu College, University of Delhi in 2017 with an aggregate of 77%. After that, I did my master's in mathematics from Pandit Jawaharlal Nehru College, MDU Rohtak in 2019 with an aggregate of 8.15 CGPA. Then I did my Bachelor of Education, Science and Arts with Mathematics from RC Chaudhry Ranbir Singh University in 2022 with an aggregate of 71%. Then I qualified the Central Teaching Eligibility Test and Haryana Teaching Eligibility Test, that is HTET. Then later on in this year, I qualified GATE exam of mathematics, and the last one is I qualified CSI UGC NET 2023 with All India rank 4. Now the courses undertaken in my BSc Maths honors are differential and vector calculus, real and complex analysis, linear and modern algebra, numerical method and programming, differential equation and mathematical modeling, and the last one is linear programming and theory of games. These are the courses, these are the topics which I undertake in BSc Maths honors. Now in MSc Maths, first topic is partial differential equation, ordinary differential equation, mathematical statistics, integral equation and COV, operational research, discrete mathematics, graph theory, and the last one is mathematical analysis. Now let us start my presentation on linear algebra. The outlines of my presentation is vector space, linear transformation, and the last one is diagonalization. First of all, what is a vector space? What is a vector space? Can anyone tell me? So the definition of vector space is a non-empty set of elements V over the field किस field पर ले रहे हैं हम F field पर define on two operations, that is vector addition and scalar multiplication, such that eight properties holds. Four properties of vector addition and four properties of scalar multiplication, right? What is commutativity? Let us see commutativity, right? Commutativity is the, one second, commutativity, right? ये हम किस में देख रहे हैं प्रॉपर्टीज वेक्टर एडिशन में. So if x and y belongs to V, then x plus y is equals to y plus x. If this is holds, then it becomes commutativity. Then second property is associativity. Everyone knows about associativity. Associativity is x plus y plus z is equals to x plus y plus z, where x, y and z belongs to vectors V, right? This is the second property. Then existence of identity. Existence of identity is third one. X plus 0 is equals to x. Here 0 is the identity, right? And the last one is inverse. Suppose that if x is a vector in V, then there exist there exist y such that x plus y is equals to 0, right? So these are the properties of four properties of vector addition. Now, four properties of scalar multiplication is for each element x in V, 1 into x is equals to x, and for each pair a comma b in F is implies that ab into x is equals to a into bx, and two properties of distributivity under scalar multiplication. What are those properties? Those properties are, now let us see here. Those properties are a into x plus y is equals to ax plus ay, and a plus bx is equals to ax plus bx. These are the distributivity under multiplication, right? So all these are the properties of vector spaces. Now example of vector spaces. First one is Rn over R and scale matrices, square matrices of order n cross n. Example of not a vector spaces are real number over complex number and rationals over real numbers. Here scalar multiplication property does not holds. By if we take x is equals to 2 and alpha is equals to root 2, then q over r does not satisfy. How? Root 2 in, into 2 does not belongs to the q, right? Now we come to the subspaces, right? A subset W of a vector space V is a subspace of V if and only if for all x comma y belongs to W and alpha and beta belongs to scalars. Then alpha x in plus beta y belongs to the W. Then it becomes a subspace W of a vector space V. Right? Now there are two theorems that any intersection of subspace of a vector space V is a subspace of V. मीन्स हम कितने भी सबस्पेसेस का इंटरसेक्शन ले लें तो वो क्या बन जाएंगे, वो क्या बनेगा, ऑलवेज सबस्पेस बन जाएगा V का. लेकिन यूनियन कब बनता है टू सबस्पेसेस का सबस्पेस? इफ वन इज कंटेन इन द अदर, दैट इज either W1 contained in W2 or W2 contained in W1, right? So these are the definitions of vector space and the subspace. Thank you guys. Next we will done in the uh, next video.